Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 8-4 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to assess the fit of a function by analyzing the residuals. Ugh, that sounds hideous, doesn't it? So let's talk about what that means. So we have a bit of data here that they've gone ahead and they've put on a scatter plot. All right. I shouldn't say scatter plot. They just graphed the points. Okay. And so what we're trying to do is we're trying to find a polynomial that's going to kind of model that data. Okay. What is the equation of a parabola that's roughly going to get you those points? And we're trying to figure out if the quadratic that they're proposing is a good quadratic for that model or if it kind of sucks. Okay. So it says each year for the past 5 years, ticket prices for a school play have increased by $1. The director uses this function to represent the relationship between the number of price increases and the average predicted revenue per show that is shown in the table. How well does the function represent the revenue data? Okay. So the first thing that they're doing is they're finding what's called a residual. Okay. A residual is just the distance from the estimated value to the actual value. Okay, I'm going to go ahead and write this out. So again, the distance from the estimated value to the actual value. So it's like all these vertical distances that you see here. Okay. And so the first thing that they did was they actually calculated what those differences were. So the average revenue was the actual money that they made. And the predicted revenue is what this line is assuming they would make. And they just subtracted the predicted from the average. I think that they actually meant to write actual here. But you know, we won't judge them. So again, the formula I'm going to write for the residual is the actual minus the predicted value. And so that's what they found here. These are all those vertical distances that I showed here. Okay. So step 2, a lot of times what they do is what they did here was they actually graphed it on the same coordinate plane. They put it into Desmos. On step 3, what they did was they created what's called a residual plot. All right, so Desmos does it for us when we go to do regression. I'll share a regression video on that later. But what they did was now they took these residuals and they put them on a horizontal graph. All right, so the -5, you see 13, 8, -5, and 10. And so they're comparing those residuals. So you can see there's some above the line and some below the line. In essence, we're trying to make it to where if I add all the residuals together, we're trying to get as close to 0 as possible. So this one is a reasonably okay fit because there's some above and some below. All right, that's kind of their point here. So now in the try it, what they're doing is they actually give you like a Desmos graph to manipulate. I'm going to show you how to create this in Desmos on your own. But they want us to make a residual plot and describe how the function fits the data. And so what's interesting about this is they don't actually do a real regression on it, which I thought was interesting. So if you notice, I went ahead and I'm just creating the table that they have right here. Except I'm not filling in N and D, I'm just filling in X and Y1. And so by generating this table, what we're doing is we're giving ourselves the ability to create this linear regression. So they went ahead, they have their own regression here. I'm going to go ahead and hide it for a moment, just to show you how to do a regression, okay? Now this is called a quadratic regression because I'm doing it with a quadratic function. And so for my regression, do you see how I'm using the tilde here? And then I'm just writing out the standard form of a quadratic. Oh, I'm doing something wrong. Oh, I forgot the y1 and x1. Whenever we have y's, I need to put y sub 1 because that's going to reference to my table. And whenever I put my x's, I need to put the sub 1 on my x's. And so to put that like subscript downstairs, I hold down shift and I hit the dash key that's after 0. So see, it's giving me the perfect line of best fit for this one. And so that r squared value of 0.98, that's telling you that that's a pretty dang good fit. Now notice the values that they get for A, B, and C on my regression aren't quite as good as the values of the one that Savvas is giving us. So is Savvas finding the line of best fit? No. But we are seeing if this is going to produce a close enough. See how different those are? Ugh. Okay. So now that I've shown you where that comes from, what I'm going to do is I'm going to create a third table that I'm going to call the residual plot. Okay. I'm going to remove my stuff I was just showing you extra. So this is going to be the residual line. I'm going to go ahead and write that in here. And so what I need to do is I need to plug in these values for x to get the actual value. Now, I'm lazy. You guys know I'm lazy. So what I'm doing is I'm actually just typing x equals, and it's going to give me the exact value. So at 0, I got 745. Oh, this would be the estimated value, not my residual. So this would be 745. Is it not going to let me type in there? Thanks, Desmos. We'll come back over here and I guess make my own table. Alright, so now let's try it when x equals 1. So when x equals 1, my estimate is 832. When x equals 2, my estimated value is 903. When x equals 3, my estimated value is 958. And when x equals 4, 1010. Alright, so they went ahead and they tell you to put the residuals in column 3, but I otherwise wouldn't have had anywhere to write my estimated value, okay? So I would put residuals and just do another column here, but I don't think I'll have enough room. So I'm just going to write it here. Alright, so there's my x values. So my residuals, again, I take the actual and I subtract the estimate, just like we did here, right? So this was the actual, they just typoed it, and they subtracted the predicted. So 730 minus 745 is going to get me negative 15. 850 minus 832 gives me 18. 930 minus 903 gives me 27. 951 minus 958 gives me negative 7. And 1010 and 1010 gives me a residual of 0. So if I were to come over here onto their graph, I'm going to extend that line a little bit. I'm going to do a residual plot down here at the bottom. Now, if you were to continue with my regression thing that I had done on here, it produces the residual plot for you, which is nice. Okay, so 0 is negative 15, which would be like here. 1 is 18, which would have been like, I don't know, slightly higher. 2 would have been 27. 3 would have been negative 7. And 4 would have been 0. Mind you, I'm scaling mine differently than this. Ignore those x values. But you can see some are above, some are below, so they're saying that that would be the best fit. Now remember how I told you that they didn't find their line of best fit for these values? I had a different quadratic, didn't I? Because look at that. See how high up these are dragging this? But these ones are so close. So because there's more net ones that are way up higher, like if I were to add some of the lines and subtract the lines, and it's not super close to 0, that's what made it not the best fit. Okay. So there we have it, guys. There is how to assess the fit of a function by analyzing residuals. Until next time.